Good morning, everyone. I'm Kaushika from the Government College of Engineering, Tirunelveli. And today I'm going to present my embedded system project washing machine simulation using an PIC16F877A microcontroller. This project was done as per the part of my internship at the EMERTXE. The goal of this project is to simulate the working of a washing machine that can perform a washing, rinsing, spinning, drying operation just like a real automatic washing machine. So, what is embedded system? An embedded system is a microcontrolled based system. It's designed to perform a specific function. It has combinations of hardware and software. So it's like a tinny computer. It's built for a one job. In our case, the job is controlling a washing machine, and we used a PIC16F877A microcontroller and programmed in a embedded C. Then what about the embedded C? Embedded C is a version of the C language used to program a microcontroller and embedded system. So it directly provided control over hardwares like ports, timer, interrupt, and peripherals. In our project, the C code was written in a MPLAB using an XC8 compiler. What is state machine logic? Normally in a program, C program or any program, we use the if else condition. Instead of writing in a long if else, we used a state machine design. So this make a washing machine work in a step by step controlled stages. Like that's example shown in the slide. Switch state case power on, likewise power on, and washing process, draining process, after that spinning, rinsing, spinning, drying. Likewise the process are done step by step to control. So that's why we used it in this project state machine logic in the program instead of using an if else. Project requirement. In our project, we use both software tools and virtual hardware component. The heart of the system is the PIC16F877A microcontroller. We used a MPLAB XID to write a code and a XC8 compiler to generate a hex file and a PIC SIMPLAB to simulate the washing machine behavior. So, another components like input unit is a digital keypad, and others are in output units buzzer, fan, heater, CLCD, and also we uses in some modular drive files for a better control and reusability. Block diagram. Here the block diagram of our system. At the center is the PIC16F877A microcontroller, which reads the input from the keypad and process it and drive the output like a LCD, CLCD, buzzer, fan, and heater. So the each module is controlled through a GPIO pins. What is mean by GPIO pins? We already know about it. It's a general purpose input output pins and modular driver code. So this diagram reflects how the actual embedded control system work in a consumer appliance. PIC16F877A microcontroller. It is an 8-bit microcontroller and widely used in an embedded project. Almost it has 40 pins with the multiple input output ports. Port A, port B, likewise. So it's perfect for controlling and peripherals. They have some features like 8K flash memory for program storage, 368 bytes RAM, 256 bytes EEPROM, 33 input output pins and 8 channel 10-bit ADC, 3 timer and USART. In our project, the port B handle and a keypad input, likewise they shown it. And after the and it's also we have to CLCD. It's a character LCD 16 cross 4. A CLCD. It's a display device that shows a text. So what is meant by a 16 cross 4? A 16 cross 4 means for per row it has a 16 character. So totally a 4 rows. It technically features, it's based on the HD44780 LCD driver and work in a 4-bit or in a 8-bit data mode. In a particularly in our project, why we used an a CLCD instead of an LCD? We already know about it LCD. So the LCD is a liquid crystal display. Is a general term for all type of LCD like graphics, character, TFT, OLED, etc. But in a CLCD, it's a character LCD, we already know, and it's also a type of LCD, but it will only display an alphabetic and numeric. That's why they set alphanumeric characters. They didn't display shown in the display as a image or in a pixel. They only show a alphanumeric characters. Digital keypad. In our project, we used a 4x4 digital keypad. So the matrix keypad or an individual switch that connected to an GPIO pins. So it is used to get a user input. Like if we press the key button 5, it's power on or to start the machine to program. So how it's work? It continuously poll the input pins and RB not to RB, any of the pin in between the 0 to 7 to check if a key is pressed. So each key has a unique binary values. In our project, we used a keypad to trigger some of the transmission, like key 5 for to start power on, and key 3 to select a program, and key 6 to pause or stop the program. Buzzer. Buzzer is used to give a sound alert like when the process start, end, or if there is an error. So it connected to a digital output pin and we control it using a symbol on off logic in our C code. So when the GPIO pins is high, the buzzer sound. So in our project the buzzers are triggered at the start of the washing and end of the washing and if an error or invalid key presses. So it is controlled by an on off logic like basis. Fan. Next fan. The fan represents the dryer motor in our simulation. So during the drying stage, we turn on the fan using a digital output pin and off after a delay. So it simulates how the cloth gets dried in the last stage, and again this is done with the simple logic in the embedded C. Tackle switch. It's also called as a push button. So it is a momentary push button switch that make a contact when the key or something like the metallic is contact when pressed. So used to simulate a manual input because we manually we are pressing the switch button. So how it's work? Connected to a GPIO pins with a pull up or a pull down resistor. So detect a low or a high signal when pressed. In our project, the keypad button is like a tackle switch. So pressing a key 5 means it's pressing a tackle switch at an RP5. You can clearly understand in the upcoming of the simulation process. We have to load a hex file. Before that I forgot to mention it, and you have to choose a board, PIC16 and microcontroller PIC16F877A, and timing you have to set 20, and LCD are 2 16x2 two types, and another one is 16x4. In our project we used a 16x4. Yes. They set power key, press key 5 to power on. So RB4 powering on the washing machine is process. To choose an option or select a program, we have to press the RB3. Heavy, delicious, delicates, white, stain, woolen, bedsheet, rinse plus dry, dry only, wash only, like this we have. In daily, by selecting that long pressing the RB3 again. it show a water level, auto, low, medium. To select, again press the RB3. To particularly select, for selecting a long press the RB3, we press. After that press the switch to start and stop, and SW5 RB4 to start. So program daily and function is wash. 5 for start and 6 for pause. The fan be rotated. Temperature cooler. In a particular, after the stage, the process is go to rinse, and after spin likewise. For pausing, we do press and a 6. Then the fan will be stopped. Again to start, we can click a RB4. Rinse process. 22 after. After 20, it go to spin. The fan rotated. To opening a door, we click a RB not. After the time complete, the work of processing is completed, and remove a cloth. This is the process that we done by the simulations of using a PIC16F877A. If you needed to use alternative options like a heavy, and then watering level is a high, likewise we change based on our need. So thank you all. This project really gave us a real world embedded experience by simulating an intelligent washing machine system. So I really learned how the microcontrollers or control a daily use appliance, and how the software and the hardware are work together in an embedded system. So really thank you for this opportunity to present here. Thank you all.